All right, welcome to Domain 3, Security Engineering. This is a big one. We're going to be spending a lot of time in this domain, and we are going to be talking about a lot of interesting things. Number one, concepts, principles, structures, and standards to design, implement, monitor, and secure operating systems. Equipment, networks, applications, and those controls to enforce confidentiality, integrity, and availability, which includes cryptography, but operating system and CPU security is something that we'll be discussing. We're also going to cover the practice of applying comprehensive current and or future structures to align practices and process with core goals and strategic direction. Kind of what we're going to be talking about in the beginning of this domain, different models that we can use for development life cycles. We kind of scanned through the slides. I think you guys saw that. Cryptography, we're going to take a look at different principles, means, and methods of mathematical algorithms and data transformations to ensure integrity, confidentiality, and authenticity. That's the lion's share of the section here of this domain. And then we're going to end the domain by looking at physical security that focuses on threats, vulnerabilities, countermeasures to physically protect enterprise resources and sensitive information. It's interesting that they have that in this domain because we actually have another domain that is dedicated to physical security, which talks about lights and cameras and fences and walls and gates and whatnot. But we do talk a little bit about that in this domain. But this third bullet point is the biggest section in this particular domain. All right. What are the individual topics? Implement and manage an engineering lifecycle using security design principles. We'll talk about the fundamental concepts of security models. How do we control and implement countermeasures based on information systems security standards? We will be talking about several different standards in the beginning of this domain. Security capabilities of information systems. How do we assess and mitigate vulnerabilities of our security architectures, designs, and solution elements, including client-based applications, server-based applications, database security, large-scale parallel data systems, distributed systems using cloud computing and peer-to-peer networking, cryptographic systems, and vulnerabilities in web-based systems. We'll also talk about vulnerabilities in mobile systems, vulnerabilities in embedded devices, and cyber physical systems, in other words, network-enabled devices. We'll spend a lot of time talking about cryptography, cryptographic lifecycle, what is a symmetric algorithm, what is an asymmetric algorithm, what is elliptical curve, what is the public key infrastructure, what are digital signatures, what is digital rights management, non-repudiation of origin, integrity by using hashing algorithms and adding an additional layer of security to hashing by salting the hashes to prevent against rainbow table attacks. What are methods of cryptographic attacks? What is a brute force attack, a ciphertext only attack, a known plain text attack? How are we going to apply secure principles to our site and facility design? And we'll look at facility security, wiring closets, server rooms, media and storage facilities, evidentiary storage, restricted and work area security, data center security, the heating, ventilation, and air conditioning considerations, water issue, leakage and flooding. And yes, we do talk about fire suppression systems in this domain, kind of a strange inclusion, if you will, where we talk about different fire extinguishers and different fire suppressions, different gases or fire suppression mechanisms. And then we'll wrap up the domain.